Looks like some of you are done here. So let's go over, see how you're doing so far. So we have number one here. I'm going to label them equations A and B again so we can refer to them quickly. There really is not an easy approach to this one. So I'm going to use the addition or elimination method. So I'm going to pick variable x to get rid of because one's already positive and one's already negative. My least common multiple, I have coefficients of 3 and 2, so I need to change them into 6. So if I multiply the top equation by positive 2, it'll turn this into a positive 6x. And if I multiply the bottom equation by positive 3, it'll turn this into a negative 6x. So let's do that multiplication. So 2 times 3x, I'm going to move it down below. 2 times 3x is 6x. 2 times 2y is a positive 2y, equals 2 times 4 is 8. Now the bottom equation, 3 times negative 2x is a negative 6x. 3 times 5y is 15y, equals 3 times 29 is 87. So now I'll go ahead and I will add those equations. 6x plus negative 6x. Oops, I wrote this down wrong. This should be a 4y up here. I said 4y and I wrote down 2y. That'll make a big difference. Now we'll add the equations. 6x plus negative 6x cancels out. 0x. 4y plus 5y is 19y equals 8 plus 87 is 95. Now we're going to divide by 19 to solve for y. We get y equals 5. 95 divided by 19 is 5. Now we still need to find x. So we go back up to one of the original equations. I'm going to go up to that top one, 3x plus 2y equals 4. 3x plus 2y is going to become 2 times 5 equals 4. And we'll solve that for x. So we can combine here. The 2 times 5 is 10. Subtract 10. Get 3x equals negative 2. And we divide by 3. Oops, sorry, not negative 2, negative 6, that should be. 3x equals negative 6. And then we divide, x equals negative 2. Getting a step ahead of myself there. So our solution here is x is negative 2 when y is 5. Now our second system of equations here, we will notice, first off, it's in the wrong order. It's not x's, y's equals constants. It's the top equation has x's, then equals, and then y's and constants. If we were going to try to do the addition elimination method here, we would have to move the y over to the left side. But since this is already x equals, this system is probably easiest to solve by simply doing substitution. I will substitute this into the other equation for x. So instead of 2x, I have 2 times 5y minus 2 plus 3y equals 9. Now I will multiply the 2, distribute the 2. 2 times 5y is 10y. And 2 times negative 2 is a negative 4. The 3y is outside the parentheses, so it does not get multiplied. It just stays 3y for now. Now we do have to combine the 10y and 3y make 13y minus 4 equals 9. We'll add 4 to both sides. 13y equals 13. And we divide by 3, or divide by 13, I should say, to get y equals 1. Now that we have y, we need to find x. Well, that top equation is already solved for x. X equals 5y minus 12. So x equals 5y becomes 5 times 1 minus, not minus 12, minus 2. Sorry, my mouth is not working today. X equals 5 times 1 minus 2. We combine, the 5 times 1 is 5. Just doing order of operations here now. And 5 minus 2 is 3, so x equals 3. So our solution to that system was x equals 3 when y equals 1. That one was a lot less work to solve with substitution than it would have been to rearrange the equations to do that addition or elimination. Number 3, both equations are set as y equals. So you could just put them equal to each other and do substitution and solve it, but we would have to work with those ugly fractions. This is one that's actually pretty simple to solve with graphing. You won't hear me say that very often, but here's one where it's true. So I'll graph the top equation in blue. We go down to -1 is where we're going to start. That's the minus 1. Slope of 3/4. So we're going to rise 1, 2, 3, and run 1, 2, 3, 4. There's our second point. Our line goes through those points. We'll graph the bottom equation in green. That starts out at a +4. That's the first point there. And the -2 slope means it goes down 1, runs 2. We go down 1, and run 2 again, puts us right there. These points, I draw the line through, they obviously cross at this one point here that was 4, 2. So we all probably at this point have our favorite method, or the method we like best, that we think we make the fewest mistakes at, or we think we solve them the quickest at, for solving these systems of equations. But as you can see with these examples, it pays to be able to do every system and every method, because there are certain systems. This one here definitely was easier to solve with substitution. This one you can make an argument a couple of different ways. But still, if you lock into that addition or elimination method, this one would have been a real bear to try to solve that way, trying to get things equal with all those fractions in it. So it pays to have different methods that you are capable of using depending on what the system looks like. Now today, part of our goal here today, I'll just put you in, there's a quiz out there, quiz 12-10B. And what I'm going to do is I'm actually going to fill most of the class time today with lecture examples and review. So even though that says it's due on the 24th, we'll make it due on the November 25th at noon. And class time tomorrow, November 24th, is going to be dedicated to the quiz. So what that means is tomorrow there will be no new lecture. And no homework other than the quiz. So all that is going to be tomorrow is just do that quiz and get it turned in. I will.
We have a test too. We have a test too, right?
Your test is not. I'm pushing that back until Monday, just because I want to do a little bit more review today rather than forcing things along. This stuff is pretty tricky, and I want to make sure we've taken plenty of time to review it and go over it. So that's actually the next place I was going, is November 30th, which is next Monday, will be test 2. I won't give you the full 2 hours to do the test, but I will give you, what I'm going to do is I will lecture from 12:30 to 1:20 that day. And then I will give you the second hour as time for the test. So I won't give you the whole 2 hours for the test. I will still lecture. That'll actually be starting unit 4 in that first hour. Part of the reason I'm doing that is I actually have to be. I teach a construction academy at Clayton High School, and because their building is going to be locked, the only thing that's going to be open is their shop. I actually have to go there that Monday and teach their what I need for them from 2:30 till 3:30. So I need that extra hour to do the travel. So complete disclosure, that's part of the reason I've changed the schedule. But I want to make sure we take plenty of time this week to review. My other section of this class only meets for 1 hour this week because they don't have class on Monday. They're 2-hour classes on Friday. So it kind of keeps your sections balanced a little bit as well. You guys have the extra time in the schedule. I want to make darn sure we're good with it. So I want to give you a couple of systems of equations to solve by graphing. So the first one I'm going to give you will be y equals negative 3/2 x plus 5, and y equals 1/4 x minus 1. Actually, minus 2, I should say. Second system I'm going to give you let's see here. 4x plus 2y, that has to do 3x plus 2y. $12 and let's do x plus 4y equals 3x plus 4y equals 15. Well, have you solved those two systems using graphing? We'll go over them in just a couple minutes, and we'll see how you did on them. Okay, let's take a look, see how you're doing with these. So for number one, both of these are in graphing form, so they're ready to graph pretty quickly. Y equals negative 3/2 x plus 5. Well, the 5 is our y-intercept, so we start by going up 1, 2, 3, 4, 5 from the origin. That's our first point on that line. The negative 3/2 multiplying x is our slope, so we go down 3, run 2, get our second point. Well, let's do it one more time. Down 3, run 2, get a third point. And our line goes through those points. For the second equation, y equals 1/4 x minus 2. Well, minus 2 is where we start. But from the origin, we go down 2. That's our first point on the line. And a slope of 1/4, meaning we go up 1 and we run 4. Our line goes through those points. It's pretty easy to see our point of intersection there is at 4, negative 1. So that's the solution to that system. Now, the second system here is going to require some rearranging. So I'm going to do equation B first. I'm going to start by subtracting 3x. So we have 4y equals 15 minus 3x. And I am going to divide by 4. So we have y equals 15 divided by 4 is 3 3/4 minus negative 3x divided by 4 is a negative 3/4 x. So y equals 3 3/4 minus 3/4 x. So that means 3 3/4 is right here. That's where we're going to start. Now the minus 3/4 slope, I could go down 3 and run 4, or I could treat it as a negative 3/4 over 1, where I go down 3/4 and over 1. I can get away with that as well. For now, we're going to go down 3 and run 4. Just to get an idea of where that second point is. So there's our line there. Now we're going to look at equation A. 3x plus 2y equals 12. To solve that, we're going to subtract 3x. So 2y equals 12 minus 3x. And divide by 2. Y equals 6 minus 3 halves, negative 3 halves, divided by 2 is a negative 3 over 2x. So negative 3x divided by 2 is negative 3 halves x. So for that one, we're starting at a positive 6 right here. And we're going down 3 over 2. Let's do it one more time. Down 3 over 2. And our lines go through those points. Now, because that equation B started out on a fraction, this one is really tough to see where they cross. They actually do cross at a fraction there. I don't know if anybody came up with a solution graphing, but it would have been very tough to come up with an exact solution. Because that one comes out to be a fraction or a decimal, this would have been one that I would have rather have solved using, actually probably the addition method, using elimination. The exact values here I would have just multiplied the top equation by a negative 1, which would have given me a negative 3x minus 2y equals negative 12. That's equation A. Equation B would still be 3x plus 4y equals 15. We could add them. Negative 3x and 3x cancel. Negative 2y and positive 4y is 2y equals negative 12 and 15 is 3. So when we divide by 2 here, we get y equals 1.5 or 3.5. And then we can put that back in to find x. We'll just use the bottom equation. 3x plus 4y will become 4 times 1.5 equals 15. 4 times 1.5 is 6. So 3x plus 6 equals 15. Subtract 6. 3x equals 9. And divide by 3. X equals 3. So even though that's relatively simple fractions or decimals, 1.5 and then a 3 is actually a whole number, trying to find that off the graph would have been next to impossible. So like I said, you have to have multiple methods in your repertoire in order to solve these. Now, I realize I told you to solve that one by graphing, so it's not your fault if you didn't do it a different way. But I just wanted to illustrate how frustrating it can be trying to find a solution by graphing to some of those systems. So I'm going to give you two more here that I want you to solve by substitution. And both of these will be fairly easy to solve by substitution. So we're going to do 3x plus 5y equals 9. And x plus 2y equals 4. And our second one, two x minus 3y is going to equal 13. And 5x plus y equals 24. So I'll give you a few minutes to solve the two of them using substitution. I realize you might not have both of them done, but hopefully you have the first one done. Let's take a look and see how you did on that one at least. For both of these, I gave you one equation where there was one variable that was obvious to solve for, obviously easier to solve for. In problem 1 here, it was equation B solving for x. So we'll do that. We'll solve for x by subtracting 2y to get x equals 4 minus 2y. That's our new equation B. Now, of course, that has to go up into equation A. 3x is going to become 3. We will replace x with 4 minus 2y plus 5y equals 9. Now we can solve that for y. We'll multiply the 3. 3 times 4 is 12. 3 times negative 2y is negative 6y. 5y is not in the parentheses, so it doesn't get multiplied. We do still have to combine negative 6y and 5y as a negative 1y, or just a negative y. I'm going to leave the negative 1 on it so I remember I have to divide by the negative 1. Now, we'll subtract the 12. Negative 1y equals negative 3, and divide by 3, or divide by negative 1, sorry, to get that y equals 3. Now I have to find x, but I have this equation that's already solved for x. So x equals 4 minus 2y. Well, minus 2y becomes minus 2 times 3. 2 times 3 is 6. So 4 minus 6, x equals negative 2. So our solution there is x is negative 2 and y is 3. The second one here, the easy variable to solve for is equation y, or equation B solving for y. So we'll solve for y there by subtracting 5x, giving us that y equals 24 minus 5x. That is our new equation B. So we have to put that back into equation A. So equation A is 2x minus 3 times, in place of y, we're going to put in 24 minus 5x equals 13. And now from here, we have to multiply by the negative 3, so the 2x isn't going to change. It's still there. Negative 3 times 24 is a negative 72. Negative 3 times negative 5. Well, negative times a negative is a positive 15x. I still have to combine 2x and 15x to get 17x minus 72 is 13. Now I can start to solve it by adding 72. Get 17x equals 85. And I'll divide by 17. X equals 5. Now I need to solve for y. I've got equation B already solved for y, so I'll plug it in there. Y equals 24 minus 5x becomes 5 times 5. 5 times 5 is 25, so y equals 24 minus 25, which gives us y equals negative 1. So our solution there is x is 5 when y equals negative 1 is the solution for both equations. I'm going to give you two examples here that I want you to solve using addition, elimination, whichever you prefer to call it. So we've got 2x minus 5y equals 1. Negative 3x plus 2y equals 4. And our second one, we'll do 3x plus 2y equals 5. 5x minus 4y equals negative 21. We'll have you work on those two, and we'll go over them in a few minutes. Well, it is 1:20. Normally it'd be time for our break, but does anybody have any objections to working through break and just getting done 10 minutes early? Okay, good. So we'll keep going here. Give us a chance. If you do need a break, feel free to get up and go whenever you need to. So let's go through these two systems here. Both of them are set up in the correct. Oops, did somebody have a question? Both of them are set up in the correct order. Oh, sorry, go ahead. I'll wait for you. Must just be feedback in the system. Sorry. Okay, so they're both set up in that correct order: x's, y's, equal signs, and constants. So we don't have to rearrange anything in either of these. However, in the first one here, there's nothing that's going to be eliminated if we just add the equation. So I am going to eliminate the x, since my greatest common multiple there between 2 and 3 would be a 6. And 1's already negative, so I'm going to multiply the top equation by 3, bottom equation by 2. So that top equation, 3 times 2x is 6x. 3 times negative 5y is negative 15y, equals 3 times 1 is 3. On the bottom equation, 2 times negative 3x is a negative 6x. 2 times 2y is positive 4y, equals 2 times 4 is 8. Now we can go ahead and add our equations here. 6 and negative 6 is negative 6x and negative 6x is 0x, which cancels out. Negative 15 and positive 4 make a negative 11y. And 3 plus 8 is positive 11. We can divide by a negative 11, get that y equals negative 1. Well, now we need to find x. I'll go back up. Doesn't really matter which equation. Let's do the top one. 2x minus 5 times negative 1 equals 1. We'll combine 5 times negative 1 is a negative 5. So this is 2x minus a negative 5 equals 1. We're going to change that to plus a positive 5. So now we will subtract 5. Oops, this should be still a 1 there. Subtract 5 from both sides. 2x equals negative 4. And we'll divide by 2. X equals negative 2. So the solution to that system that we get is x is negative 2 and y is negative 1. The second system over here, number 2, well, again, we see that nothing cancels out. But we see that if we multiply the top equation, equation A, by just 2, then it'll be a positive 4y, and the other one's already a negative 4y. So let's do that. 2 times 3x is 6x. 2 times 2y is 4y, equals 2 times 5 is 10. Our second equation is not going to change. 5x minus 4y equals a negative 21. So now we add the equations. 6x and 5x is 11x. 4y and negative 4y is 0y. It cancels out. Equals 10 and negative 21 is negative 11. So we can divide by 11 to get that x equals negative 1. Now we have to go back to find y. Let's go back up to that top equation. 3x becomes 3 times negative 1 plus 2y equals 5. 3 times negative 1 is a negative 3 plus 2y equals 5. And now we will add 3 to both sides. 2y equals 8. And divide by 2. Y equals 4. So the solution to that system is x is -1 when y equals 4. So I am sure that the common question rattling through some of your heads right now is, why? What on earth would we ever use this for? How does this apply to construction? What good is it going to do? So we're going to talk a little bit about roof lines and trusses. And to talk about that, we first have to talk about slope, not just of a line on a graph, but how it applies to a truss. Let's just look at a monoslope truss here. Single slope is what that means. If it is noted like this, that symbol means that this is a 5/12 slope, which means, let's say this is 18 feet here, span, that 5/12 slope means that there's 5 units of rise for every 12 units of run. We can set that up as a proportion. 5/12, remember 5 is the rise, and 12 is the run, just like a slope on our graph. And that's going to equal, we know 18 here is horizontal, that's the run. We are looking for the rise. I'm going to call that h for height. To find that, like we did with percents back 9-10 weeks ago, we cross multiply. So we multiply the two numbers that are diagonal with each other. 5 times 18 is 90. And then we divide by the number that is diagonal with our missing number. So 12 is diagonal with the h, so we're going to divide by 12. That's 7.5 that we get there. We get a height of 7.5. So that's saying our height here is 7.5 feet. 18 was in feet. 7.5 is also in feet. So we can use that to find the rise. Well, how does that tie back into systems of equations? Well, we might have what's called a dual slope truss, where we want different slopes on each side. This side might be 4/12 slope, and this side a 12/12 slope. And we might be told that the span of this is 36 feet. And we might want to know x, which is the run of the 4/12 slope, and y, which is the run of the 12/12 slope. To do that, we're going to bring in a third variable, h, which is going to be that height at the peak. The reason we're doing that is because it allows us to do some rearranging. Now, the first equation we see here deals with the span. The total span is 36 feet, but x plus y adds up to that total span. So that's our first equation here, our most obvious equation. We need a second equation, either in terms of x or y, or some way to turn x and y into the same variable so that we can solve. That's where the h comes in. So first we're going to look at this side over here. On that side there, we have a run of x, a height of h, and it is a 4/12 slope. That's saying 4 over 12 equals the rise of h and the run of x. And here we can't just cross multiply and divide. Here we actually have to do a full cross multiplication and set the cross products equal. So we have 12 times h is 12h, and 4 times x is 4x. We know that 12h equals 4x. I can solve that equation for x by dividing by 4. Gives me that 3h equals x, or x equals 3h. What that means is I'm going to come up here and I'm going to put 3h in where the x is. Now you might say, well, that doesn't do any good. We still have two variables, but we still have to look at the opposite side over here, this piece. As we look at that piece, we have a height of h, span or run of y, the 12-12 slope. So we know that 12 over 12 equals h is my rise and y is my run. When I do my cross products here, I have 12 times y is 12y equals 12 times h is 12h. And just like I solved for x in the last one, here I'm going to solve for y. It's not going to divide by y. I'm going to actually divide by 12. Divide out the 12. Y equals, well, that 12 divides out 2, just gives me h. So y equals h. So I'm going to replace y here with h. So x has already been replaced with 3h. I replace y with h, and that equals 36. Now I have one equation with just one variable. 3h plus h, now remember we think of that as being a 1h, is 4h equals 36. We can solve for h by dividing by 4. H equals 9. That tells us that this height here is 9 feet. Well, what good does that do us? Well, we have equations down here that describe x and y in terms of that height. X is equal to 3h. Well, 3h is now 3 times 9 equals x. 3 times 9 is 27. 27 equals x. Over here we have y equals h. Well, h is 9, so y equals 9. So up here, x is 27 feet, and y is 9 feet. And we should double check. 27 and 9 does add up to 36. So we found the run of each of those slopes in a dual slope truss. So let's look at another example of the same type of thing. A little bit more extreme discrepancy in slopes here. But it's still going to be the same process. For our span, we have the equation x plus y equals 42. Now we need to look at each slope separately, just like we did before. So we'll look at this one here. I'm going to call that h for height. So I have a run of x, a rise of h, and it's an 18-12 slope. So that means 18 over 12 equals my rise of h over my run of x. And I'll cross multiply. 18 times x is 18x equals 12 times h is 12h. Now, even though it's not going to come out to be a nice, neat little number like it did last time, we're still going to solve for x here by dividing by 18. X equals 2/3 of h. That means up here, x is going to be replaced with 2/3 h. Now I'm just going to leave the rest of that blank for now. I'm going to replace y in a minute, but let's figure out what we're going to replace it with. We're going to look at this triangle. So that one has a 3/12 slope, a rise of h, and a run of y. So we start with our slope of 3/12, 3 over 12, equals a rise of h over our run of y. We have 3 times y is 3y. 12 times h equals 12h. So 3y equals 12h. And just like in the last example, we'll solve for y by dividing by 3. Get y equals 4h. So replace y with 4h equals 42. Now we can combine. Never said these equations would be pretty. When we deal with applications, usually they're not. 2/3 h plus 4h is 4 2/3 h equals 42. And we have to divide by 4 2/3. This is 42 over 1 divided by 4 2/3. You guys make it improper. 4 times 3 is 12, plus 2 is 14/3. So that's 42 over 1 times, we go by the reciprocal, 3 over 14. 42 and 14 can actually both be divided by 14. 14 divided by 14 is 1, and 42 divided by 14 is 3. 3 times 3 is 9. 1 times 1 is 1. So 3 times 3 is 9. H equals 9 here. So once again, H equals 9. And we can use that to find X and Y. This tells us X is 2/3 H. So X equals 2/3 times 9. Well, 2/3 times 9 is 6. X is 6 feet. This is saying Y equals 4H. Y equals 4 times 9. 4 times 9 is 36. So Y equals 36 feet. X is 6 feet. Y is 36 feet. When we double check, they do add up. 6 and 36 add up to 42. That's not a simple process. I admit that. But it is as simplified as I can make the applications. So I'm going to give you 5/12 slope and 15/12 slope on a 40-foot total span. I want you to find X and Y. I'm going to give you a few minutes to find that. We'll go over it in 4 or 5 minutes. Okay, it's been 5 minutes. Let's take a look, see how you're doing. I know you may not be done yet. But again, we're going to describe our span here. We know that x plus y equals 40 feet is our total span. Now we look at each side of this separately. So this triangle here is a 5/12 slope. We have a run of x and a rise of h. So 5/12 equals a rise of h over run of x. And we cross multiply. 5 times x is 5x. Equals 12 times h is 12h. Now here I'm actually going to probably go with decimals. I divide by 5, I get x equals 12 divided by 5 is 2.4h. X is 2.4h, so I'm going to put 2.4 times h there. Now let's do the same for the other side to find y. For that triangle, we have run of y, rise of h, and that's a 15/12 slope. So we know a slope of 15/12 equals a rise of h over a run of y. We'll cross multiply. 15 times 12, or 15 times y is 15y, equals 12 times h is 12h. And when I divide this out, if I divide by 15, I get that y equals 15 divided by 12 is actually 0.8h. I'm going to double check that. 12 divided by 15, I should say, is 0.8. So y equals 0.8h. So at 2.4h plus 0.4 or 0.8h equals 40. The 2.4 plus 0.8 is 3.2h equals 40. And we'll divide by 3.2. H equals 40 divided by 3.2 is 12.5. So h here is 12.5 feet. Now we go back down to each of these. X is 2.4 times h, that's 2.4 times 12.5, which is 30. Y is 0.8 h, so 0.8 times 12.5, which I believe is 10, but let's double check it. It is, y equals 10. So we get x equals 30 feet, y equals 10 feet. How many of you got that? How many feel like you could get it if I gave you a little more time?
Yeah, maybe if I had a little bit more time.
Okay. How many hope this never shows up on a quiz or a test? Well,
Sounds like you're talking about the last week or so's worth of work.
Yeah, the systems of equations themselves are not simple. This application, anytime you throw a math concept into practical application, for some people it's easier because it makes more sense. You can see the use for it. But generally, the application clouds the math concept a little bit. There's little adjustments you have to make. Like here, it's adding in the rise and run for the slope so that you can come up with those numbers, those values for h to substitute for x and y. The good news is the trusses will not show up. The roof lines and roof slopes will not show up on a quiz this semester. Next semester, we will go over this all again in the ratio and proportion and introduction to trig stuff. So it will appear on a quiz at some point, but not in the next 3.5 weeks. Now, of course, it doesn't stay that easy. In real life, these trusses don't come down to a point. They have what we call a heel height. This is a heel height. So if we add in a length of a heel, let's say this one's 8 inches high and this one over here is 6 inches high. Let's say we have an 8/12 slope there and a 3/12 slope here. We are still dividing this up as x and y. So we still know, as far as our span is concerned, x plus y adds up to 30. Well, now we need to find our triangles to find our other equations for h. Now this whole height here is h. So if I draw out that green triangle that I just did, the run is x. The height here is h minus 8 inches. Well, h is in feet, so I'm going to have to put 8/12 to turn my 8 inches into 8/12 of a foot. And that slope is an 8/12 slope. So I have my slope of 8/12, that's from this, equals a rise of h minus 8/12 over x. And now I have to multiply. So 8 times x is just 8x, equals 12 times h minus 8/12. It's going to look like this. Then I have to distribute the 12. 12 times h is 12h. 12 times negative 8/12. Well, 12/1 times 8/12. The 12's just cross cancel. That's just 8. But we can't forget there's a negative 8. So that's 8x equals 12h minus 8. And now I can divide by 8 to solve for x. X equals 12h divided by 8. Well, 12/8 is actually just 1.5h. Negative 8 divided by 8 is a negative 1. So x equals 1.5h minus 1. So x here, 1.5h minus 1 is what's going to go in there. Now we have to do something similar for y over here. This is y. This is a 3/12 slope. This height here is h minus 6 inches. Again, that's h minus 6/12, since that's 6 inches and is in inches, and the 12h is in feet, so it's 6/12 of a foot. So we have our 3/12 slope from this equals our rise of h minus 6/12 over our run of y. So we've got 3 times y is 3y equals 12 times h minus 6/12. Well, 12 times h is 12h. 12 minus times a negative 6/12. So the 12's cross cancel again. That's just a negative 6. And we divide by 3 to solve for y. So y equals 12h divided by 3 is 4h. Negative 6 divided by 3 is a negative 2. So y equals 4h minus 2. So I've got negative, or 1.5h minus 1 plus 4h minus 2 equals 30. So I can combine 1.5 and 4 is 5.5h. Negative 1 and negative 2 is negative 3 equals 30. So I'll start solving this by adding 3. 5.5h is 33. And now we finish to solve for h by dividing by 5.5. H equals 6. Now that we know that h equals 6, we can find x and y. X equals 1.5h, that's 1.5 times 6 minus 1. 1.5 times 6 is 9. 9 minus 1 is 8. So x equals 8. Y equals 4h. 4 times 6 minus 2. 4 times 6 is 24. Minus 2. 24 minus 2 is 22. So y is 22. So x is 8. Y is 22 feet, of course. And that does add up to our total of 30 feet. The good news is, even next semester, this would be an extra credit question. Just to let you off the hook a little bit. Another example would be a porch truss. A porch truss is a truss that is built. A common truss, let me say this, is just one where both sides are the same slope like this. Well, a porch truss starts out with like a common truss, but then has a piece that sticks out like this at a lower slope, so that wherever this would normally come down is where the wall is. This piece hangs out over the end to make a porch. But when building these, you need to know how long to make each of these pieces. Know how long to make each of those pieces, you need to know what their run is. So I'm going to come down from the peak there, and then I'm going to come down. We call this a pitch break. It's where the slope changes from one to the other. Call this 612 here. This slope is also 612. And where the porch is, it reduces to a 312 slope. We're going to give you an overall span of 36 feet, and we're going to call this here, what do I want there? Let's call it 12 feet. Let's see what happens. So the one thing we know here is that this total span from here to here has to be 24 feet. And of course, what we're trying to find is x and y. So we know, based off of our span, that x plus y equals 24. Now, these two triangles here don't equal the same height. They add up to a height. And in this case, we can find this height if I set that triangle up with a 612 slope with a 12-foot run, and that's my height. I know that 6 over 12 equals h over 12. If I cross multiply and divide here, I get h equals 6. So this height here is just 6 feet. Now I have to introduce a couple of other variables here in order to solve this. I'm going to call the rise of this 312 piece A and the rise of the 612 piece B. So I know from that A plus b equals 6. Well, I haven't helped anything here because all I'm doing is making more equations with more variables. So I have to get rid of a couple variables here. I only want 2 equations with 2 variables. So we're going to be able to get rid of a and b here by looking at, well, let's start by looking at this triangle here. I know that as a rise of b, a run of x, and it is a 612 slope. So 612 slope equals a rise of b over a run of x. So I've got 6 times x is 6x equals 12 times b is 12b. I'm going to solve that for x by dividing by 6. X equals 2b. So what that means is I'm going to be able to replace this x with a 2b. Let's figure out what we can replace y with, and then we'll go from there. We're going to look at this triangle here. Has a rise of a and a run of y, and it's a 312 slope. So I know 3 over 12 equals a rise of a over a run of y. 3 times y is 3y equals 12 times a is 12a. And I'm going to solve for y by dividing by 3. Y equals 4a. So that means I can replace y here with 4a. So my system of equations now becomes, this becomes 2b, actually I'm going to change it around, we'll put the 4a first. 4a plus 2b equals 24. And this one, of course, still stays a plus b equals 6. But I'm going to do this. I'm going to multiply that equation by negative 2. So negative 2 times a is negative 2a. Negative 2 times b is a negative 2b. You can see why I'm multiplying by negative 2 now, so that the b's will cancel out. And negative 2 times 6 is a negative 12. So now I can do my addition. 4 plus negative 2 is 2a. 2b and negative 2b is 0b, cancels out. 24 plus negative 12 is 12. We can divide by 2, solve for a here. Get that a equals 6. So a here is 6 feet. That means that b has to be 0 feet, because a plus b adds up to 6. So b is 0 feet, a is 6 feet. Well, if b is 0 feet, that means x has to be 0 feet, and y is the full 24 feet. That one didn't work out very well. I should adjust that one. Okay, it is that time. We're actually like 4 minutes early, but remember we skipped our break, so it should be done at 3:10. Remember, there's a quiz tomorrow. It's out there, so you can start working on it today if you would like. I will log into class. I'll be on, if people need me and have questions, I'll be on the full hour. Otherwise, if nobody comes in the first 10 or 15 minutes, I'll log out after that. But I will be in the classroom if you have questions on the quiz, or if you have any quiz corrections or anything that you need help with, feel free to bring those into class, and I will help you with those as well. Like I said, we got just under 4 minutes left here. If you'd like to work on anything, I'll be on the network here to answer questions.